Welcome to this recorded video for students in the operations course to learn about expected value as one objective of this short video. And the other objective is to look at how we build this solution in Excel for those who are practicing their Excel skills. All right, so it'll probably go a little slow for those who are Excel wizards, but I want anybody that's trying to get more familiar with Excel to get that double benefit. So expected value, there's a definition I posted up here for you that's a pretty good one. Expected value, a calculation that summarizes the expected costs, revenues, or profits of a capacity alternative based on several demand levels, each of which has a different probability. What does that mean? It means that if we are establishing additional capacity and we want to model several different options, could be 2, could be 10, all right? I hope it's not 10, but it could be 10. And we want to model that out. And then we want to say, demand, because capacity is being established to satisfy demand, right? So demand levels can have an impact on which decision is best. And what we can do is model different levels of demand and establish the probability that we think those different levels will have, and then drop in a better informed, indicator of what a good decision might be. So let's look at one here. We'll have a fictional example, option 1 and 2. Plug in whatever you want for option 1 and 2, right? But there's a million things you could put in there. We could say we need more stamping press capacity, right? We need more press capacity, and we can buy new or we can buy used. If we buy new, it's $500,000. And if we buy used, it's $100,000. And if we buy the new, we get a low piece price because it's new efficient equipment of $2. If we buy used, it's poor efficiency and or much less efficient cost per unit of $10. You could apply that in so many different things, right? Should we build a warehouse or should we lease a warehouse? Should we buy trucks for our fleet, or should we ship through common carriers and just have a nominal fixed cost per year and high variable? Should we, you could apply it to a lot of different scenarios, right? So in any case, we've got option 1 and 2. We'll call it a used and new piece of equipment for this and get on with the calculations here. So how would we do it? Okay, first notice down here that we've established 3 demand scenarios: 25,000 pieces, 60,000 pieces, and 100,000 pieces. Let's just say that everything's per year here, right? These are per year cost fixed, and these are per year volumes. And we've also said that the probability of those 3 kind of alternative futures are 30% that we'll do around 25,000 pieces, 40% that we'll do 60,000 pieces, and 30% that we'll do 100,000 pieces. All right, those are eerily close percentages. A lot of times what you would really see in a business would be more likely, and I want you to think about this, that we came up with a business plan and we said we think we're going to sell 60,000 pieces next year of this widget. And so this is this 40% might be a lot higher in a lot of scenarios where we say, well, there's probably a 60 or 70% chance that that's going to happen, 50, 60, 70%, right? It's a higher, more confidence in that most likely probability. This doesn't have a lot higher confidence in the most likely probability than these 2 other very different probabilities, right? So there's a lack of confidence in this organization in their future. But that's the reality, right? So they don't have a good confidence, so they're going to weigh these 3 scenarios very similarly. They're saying, we don't know what's going to happen. We could be at 25,000 pieces. We could be at 100,000 pieces. We could be somewhere in the middle of that. So that we're going to put these kind of close probabilities on here because we just don't know. We don't have any confidence. That's something this tool can accommodate. All right, let's do the calculations. So for those learning Excel, this cell, option 1, total cost. Now remember, total cost is the fixed cost plus the variable cost times the quantity. the fixed cost plus the variable cost times the quantity. And we're going to drop that into every one of these fields for the scenario we're looking at. So this would be equals the fixed cost of $500,000, and I just click that with my mouse, put the plus sign in, the variable cost times, which is the star key, the volume. Hit enter, and I get my answer. Now, it's a good habit for those learning Excel to always bracket those parts of the equation which we know should be bracketed because they stand alone on their own, and it'll keep you out of trouble. You saw this value didn't change, and that's okay. It's a good habit to always bracket that which should be bracketed because it'll keep you out of trouble. Okay, so let's do the next one. Equals my fixed cost plus my variable cost times my volume. All right, I've got both those fixed total cost in. I want to see my cost per unit. That is my total cost divided, whoops, not question mark, divided / the volume. Okay, so see that, how that works? I type in equals, I select this cell, I type in the / I select this cell, and then I hit return, $22, right? And we do the same thing here. Equals my cost divided by my volume. Over here is where we assign now this total cost, the weighting of the probability. So equals my total cost times this percentage, which will bring it down to 30% of that number, equals my total cost for option 2 under this demand scenario, times with the star key, hit the 30%, and we got her. That completes this. We have to do it for the other two. So we just completed for 25,000 pieces. How do my option 1 and 2 weigh in for total cost projection? And under this demand scenario being only 30% likely, what is 30% weighting of those total costs? I'm going to blow through these other two because we need to keep her moving, and you already know how this formula is built. So there we go, equals D4 plus D equals D4, D4 plus E4 times the 60,000. Boom. And again, I always encourage people to do your parentheses where you need to so you keep out of trouble. It doesn't matter here, but I don't want to show you the wrong way, the sloppy way, because then someday you'll get in trouble. Equals my fixed cost plus my variable cost times my volume. Go back up and clean up that brackets, add those parentheses in where they belong. Okay, my cost per unit under the 60,000 demand scenario. Oops, that wasn't right. Back it up. Hold on, I was here. Equals my total cost divided by my volume. Equals my total cost divided by my volume. Okay, this of course is to put the weighting on it now. My total cost with the star key times 40%. And equals my total cost, star key, times 40%. Let's do the last one, and then I'm going to show you why this can be a great tool. So, down to the higher volume equals my fixed cost plus my variable cost times my volume, and equals my fixed cost plus my variable cost times my volume. We are rolling now, equals my cost divided by my volume, equals my cost divided by my volume, and then we'll put the weight on it, equals my total cost times 30%, equals my total cost times 30%. Okay, so there we have demand scenario 1, change its color a little bit so you can see it differently, right? Demand scenario 1, and we've got demand scenario 2. That's too dark. You can't see that. That's too dark. Okay, and demand scenario 3. We'll make that guy orange. Okay, so we've got 1, 2, and 3 different possibilities, and we've got these probabilities assigned to each one. So for option 1, the new equipment, and option 2, the used equipment, we've got those blown out, and you notice this equals 100%. It must equal 100. 30, 40, and 30 is 100%. It can't be more or less than 100%, or it'll shift the values. They have to be 100% total. Okay, so how do we now turn this into a decision tool? Basically, we want to sum these 3, and that's why they have to equal 100% together. So my 165 and my 248 and my 210 need to be the total expected cost for option 1. So that would be equals 165, and I can just mouse these and hit a plus. Mouse over them, click, and hit a plus, and hit enter. And I'll get my 623, which is 165 plus 248 plus 210. And because option 2 relationship to option 1 is identical to the cells that are going to sum it to option 1, I can use the mouse over here. Remember how this works? If I get in a cell and I come down to that little dot and I get the darkened black mouse, I can click, left click, pull down 1, and have the formula copy over. I can only do that because all the relationships are the same from the cell I'm copying. All right. So what do we see here? What should management do? 623,000 is less than 715. So all other things being equal, if we don't have some information that's not in this calculation, but we should consider, like, well, we read that those presses are super reliable and actually never go down, the old one, right? Or vice versa. Let's say we've learned that those presses are really problematic and that service parts are almost impossible to find, and that people who do press maintenance are not familiar anymore. It's so old, literally stamping presses sometimes are as old as, World War II and stuff. They just run and run and run and run and get new parts put into them and keep running. So if this one's going to cause a huge maintenance error, we might say, you know what? We'll burn through the difference in this. If that maintenance information is correct, we'll burn through the difference in this. So we need we need to add some complexity into the decision process. But if this is all we know, we would say option 1, new press, and that's not surprising, at $2 per unit is the way to go. Now, one of the beauties of spreadsheets, and this is a good chance to call it out to you, is that once we've built a model, we can copy that model and run more scenarios. So we could argue about this a little bit and say, you know what? I think that purchasing can actually get the option 2 cost of $100,000. I think we can find a press for $50,000. That changes things a little bit. See them tightening up? See them tightening up over here? Option 2 started looking a little better. And this $10 per unit is hogwash. This part produces at X parts per hour, and this actually is just 2.5 times that. So it's not $10 variable cost per unit. We're going to get a lot more productivity on it. The scrap is the same. The amount of metal and labor we're going to consume is the same. So this is actually $5. And we can click that button and say, I'll be darned. Option 2 is the best scenario, right? So we can change these numbers as information gets more matured and more accurate. We can change information around and play with the model to try to make the best decision we can. Not play with it to try to bias it and sell our agenda. Play with it to try to improve it and make a great decision. Let's take another scenario and then I'll wrap it up. But here we had 30, 40, and 30% probability. Those percentages are so close. across the three different demands, which are very different, 25,000, 60,000, and 100,000. This is 4 times, right? And there's not a big swing to the middle. Many times, if we have higher confidence in our business plan, we'd be able to say a higher number of probability in the center here, right? And not have this kind of generic, we don't know what's going to happen here. 40%, 30%, 30% is awful close. So if we were to take some different probability levels and if we played with these at all, then that would also have a pretty big shift on this, right? What you can say from a reasonable point of view is we know that as volume, the more volume we get, the more option 1 is going to look good. The higher volume goes, the better that low variable cost is going to be. And I can prove that to you by basically saying there's a 60% chance of low volume and a 10% chance of high volume and a 30% chance of the middle volume. And now we see that option 2 is the lower cost, right? Because we've said we think it's most likely that we're going to be in this 25,000 range. And the more we increase that, if I make it 70% and 20% and 10%, the more it's going to swing in favor of having a low fixed cost and a high variable cost. So in the general assessment of things, we're seeing how confidence in high volumes justifies investments in equipment and plants and tools that can produce us a low variable cost, and vice versa. That low confidence in volumes keeps us more working with lower investments and lower productivity because we just don't have the volume to spread this fixed cost across. I hope that was explanatory for you. It's a little longer than I wanted it to be, but we combined learning Excel with learning about the expected value calculation. I wish you a great day, and that concludes our video.